Twice differentiable functions f and g are defined for all real numbers. X values for f, f prime, g, and g prime for various values of x are given in the table above. Find the x coordinate for each relative minimum of f on the interval from -2 to 3 and justify your answers. We are only looking at f, so we're going to ignore g for this. And we need to see a derivative that is 0, and our derivative needs to switch from what to what? Okay, the original function will switch from going down to up, which means the derivative switches from negative to positive. So that happens on your chart right here, right, negative to positive. So we're looking at it asks for just the x coordinate, so it's this 1 right here. So we would say f has a relative minimum at x equals 1 because f prime of x switches from negative to positive. Okay, questions on that? That's all you got to do for that one. You do have another critical point here, but you don't switch signs. So, all right, so for B, it says explain why there must be a value C for -1 to 1 such that f double prime of C equals 0. So, for this is asking us about the second derivative. Do we have any information about the second derivative? No. But we do have information about the first derivative, and if we want to talk about the rate of change of the first derivative, that gives a second derivative, right? So rate of change, that's going to be our mean value theorem, right? What we need to look at is from -1 to 1, we need to look at the coordinates on f prime, right? But first, before we can do anything with this first derivative and using mean value theorem, what has to be true? Okay, we have to have continuous and differentiable, but what has to be continuous and differentiable? Is it f, f prime, or f double prime? Do we care about f double prime? Just f. So like for mean value theorem, normally we're dealing with f, right? So normally f has to be continuous and differentiable. And then that tells us a conclusion about f prime, but we don't have to really know anything about f prime. We have to prove it about f. So here, our conclusion is about f double prime, which means we have to show that mean value theorem applies to the function above f double prime, which is f prime, right? So we would say since f is twice differentiable, f prime of x is continuous and differentiable on -1 to 1. Use brackets there because it has to be continuous on the closed interval, including the endpoints, and differentiable on the open interval, which your conclusion is on the open interval, but you want to put brackets there because it has to be continuous at the endpoints. And since it just generally tells us that it's twice differentiable for all real numbers x, you can make this like general conclusion that this is the case. So you can go to this. In fact, you could just leave off the interval altogether and be okay. Yeah, and just say for all real numbers, so obviously it would also be the case on this interval. I'm not sure how picky they are about stuff like that. But it would definitely be correct as we've written it here. So, mean value theorem applies. So, since we're asked about the second derivative, we're using points from the first derivative, which would be -1, 0, right? We got f of -1 equals 0, and f of 1 equals 0. Oh, sorry, I should be using primes there. Thank you. And so our average rate of change would be 0 minus 0 over 1 minus -1, 1 plus 1. Either way, we get 0 over 2, which is 0. Therefore, and then here is where you basically just restate what the question asked you, right? There must be a value C for -1 less than C less than 1 such that f double prime of C equals 0. Yes.
This doesn't change anything about it, but should the average rate change, like at the bottom, be -1 minus 1?
It can be either one. I did like 1 minus -1, so I was using like this as the first point, and it doesn't matter when you do that slope which one's the first point. So you could do it either way. So your -2 would be perfectly fine, but it doesn't matter which one. Okay. Sorry, watch. I might need to answer this because I'm getting a call. Probably fly. But it's not asking them. Probably is. They're asking me on lunch. Hello? Yes. Yes. I don't think I'll be able to because I'm a teacher and I've already got coverage for this class. I don't think I'll be able to get coverage earlier. Okay. Okay. All right. Thank you. All right. Bye. I talked to her. They're wanting to come in earlier. I mean, would I like to skip fourth period completely? Yes. But would Coach would like to watch my class the whole fourth period rather than 15 minutes? Probably not. So, sorry. Just whenever somebody calls you twice in a row, back to back, I'm worried that there's like an emergency. My kids do this to like their grandparents. Like they'll call, and if they don't answer, they'll call back and call back. Like something's wrong, but really they just need to show them this new trick they learned or something. And I fuss at them, but I've not got the message across, obviously. Probably because I've ignored their, Mom, watch this, Mom, watch this. All right. Okay. C tells us that the function h is defined by natural log of f of x, and we're supposed to find h prime of 3 and show the computations that lead to your answer. So for this derivative, you've got to do a chain rule here. And so to take the derivative of a natural log, we do 1 over whatever we're taking the natural log of. So h prime of x is going to be 1 over the inside part, which is f of x. But this is a chain rule, so we got to multiply that by the derivative of the inside, which is f prime of x. So you end up, I'm going to write that as f prime of x over f of x. Okay, here. So h prime of 3 would be f prime of 3 over f of 3. And we're going to pull those numbers from the table. We got 7 and 1/2, so we got 1/2 over 7. Technically, you can leave it like that. I just can't stop myself here to get 1 over 14. But technically, you can leave it 1/2 divided by 7. Excuse me. Okay, and the last one is similar to what we had to do for C, but this time we've got f of x times g of x. What do we have to use to take the derivative of that? Product rule. So we're going to have k prime of x is f of x times g prime of x plus g of x times f prime of x. Write that. I mean, if it were me, if I were taking the AP exam, which I always wish they'd let me do, wonder if I could pay to take it. I mean, I'm not going to, but I know they're not. No, I know they're not going to let me pay to take it and take it in the same room as you guys. Yeah. Yeah, I know they're not going to let me do that. But would they let me, like, I mean, it would be, I should do well on it. They do every year, so like 2 days after the AP exam, they'll release the free response questions, all of them. So, it's new ones if you have to take the retake. The AP is on top of the cheating thing. It's not easy to cheat on the AP exam. I'm not going to say it's impossible. Don't take that as a personal challenge. To huh? I mean, yeah.
As soon as you post the book, they fix exactly what you
I remember one time, this might be in your blood, Connor, because I remember one time that your mom said that your dad would spend 2 weeks working on a contraption to get himself out of 3 hours worth of work. So this might be similar in your cheating scheme to beat AP. So, but I guess that's kind of what engineering sort of minds do. Okay, you're going to write it on an alias. Yeah. Yeah. All right. I do not think this will be your best course of action. I do think it would be easier to just learn calculus than to figure out a foolproof way to cheat on the AP exam. But I do wish they'd let me take it. All right, so we got f of 3 is 7. G prime of 3 is negative 2. So 7 times negative 2 plus G of 3 is 1 and 1/2. And so, I mean, really, honestly, it's probably a good idea to leave it here on the AP exam. I have a hard time doing that. So you got negative 13.5, but you could leave it here. Because if you make a mistake, it could cost you a point. Make sure I didn't mess it up. Make sure we got the same answers. Yeah. Okay. Questions? Okay. Questions? All right. Your second one, I think it's a little bit easier. The graph is hard to read, but I think it's a little bit easier than the others. It's mostly just explanations from the graph. Do make sure this shows you f prime of x. That right there is supposed to say f prime of x, but obviously this is a terrible copy, right? But make sure on the second one, whatever you are answering needs to come from f prime. Your reason comes from f prime, because f prime is the only thing you can see. So, like, you can't say that it's concave down because the second derivative is negative, right? You have to say it's concave down because the first derivative is, what would the first derivative be doing? Decreasing, right? Because although it is also true that the second derivative is negative, you have to show how you know that, right? So, you can just say f prime is decreasing. You don't have to talk about second derivative at all. If you do, it's fine, but it has to also include first derivative for that. Okay. All right, so let's go look at the rest of the notes we were working on yesterday. And to make sure that we get my favorite type of problem in, let's do it first, because it's all right. Okay, this is my favorite type of problem. This particular problem is obviously not a situation where you would necessarily actually sit out there and figure this out. However, there is a similar problem I'm going to give you that I think would make a big difference. So, a boat on the ocean is 4 miles from the nearest point on a straight shoreline. That point is 6 miles from a restaurant on the shore. A woman plans to row the boat straight to a point on the shore and then walk along the shore to the restaurant. Here's the catch. She can walk at 3 miles per hour, but she can only row at 2 miles per hour. At which point on the shore should she land to minimize the total travel time? So, speaking about spending 2 weeks to get out of 3 hours of work, this is a little bit of that sort of situation right here, right? Because it's going to take us a little while to do this problem, and she probably could have just started either walking or rowing and be done with it. But there's a similar problem we're going to do with this tomorrow, hopefully for warm-up or sometime, where rather than being a person rowing and walking, you're running pipe, and you run that pipe, you either have to run the pipe under a river or along the shore, and it is more expensive to run that pipe under the river, but cheaper to run it along the shore. So certainly if you're trying to decide where to run that pipe, and you're talking, you know, millions of dollars to put all this stuff in, you're going to sit down and spend the time figuring that out. What would be cheapest, what to do, and all that. If you're on the rowboat, you may decide that it's not a big enough difference for you to spend this amount of time doing calculus. But there's a lot of good applications for this that could be higher stakes sort of situations. So let's draw a picture of what we've got here. Our straight shoreline is here. We've got our lady out here in her boat. I'm not going to draw a sail because it's a rowboat. We need to draw. Oh, she's standing up in it for some reason. Here's her paddle. Here's her other paddle. There. Boat. Alright. Okay, so she is 4 miles from the nearest point on a straight shoreline. So the nearest point on a straight shoreline would be perpendicular. So that's 4 miles. Why she is 4 miles out in the ocean in a rowboat, I don't know, but she's doing it alone. Yeah. So this point is 6 miles from a restaurant. So down here, we've got our restaurant, seafood restaurant here. And this is 6 miles. So, I'm going to consider 3 options. Okay? So, the shortest distance for her to travel is for her just to row straight to the restaurant. Don't walk at all. Just row straight there. Right? That's going to be the shortest distance. So if we did Pythagorean theorem there, there's one, 89. If we did Pythagorean theorem, and this will be calculator active, we got 4 squared plus 6 squared is going to be 7.211. So this is 7.211 miles. So if she rows straight to restaurant, then if it's 7.221 miles and she's only rowing at 2 miles per hour, how are we going to figure out how long that's going to take? We're going to divide by 2, and we get 3.606 hours. That's a lot of rowing. She's going to be hungry by the time she makes it to the restaurant. But she did go out 4 miles into the ocean on her rowboat. So perhaps.
She could just row a little faster.
That's her max speed. That's as fast as she can go.
That's her max speed. Can she do that for 3.5 hours?
She can. She can. She's well trained for this.
So why can't she?
This is the kind of woman that rows out into. This is the kind of woman that rows out into the ocean 4 miles in a rowboat alone. So no. Yeah. So.
Good current pushing her.
All right. So our other like simple option that we have here mathematically is that she rows straight to shore and then she walks this whole way. That's going to be a lot longer, but she is a faster walker than she is a rower. So, if she goes straight to shore, and walks 6 miles, then it will take her, if she got 4 miles to go to get to shore, it's going to take her 2 hours to go to shore, right? So 4 divided by 2 will give us 2 hours. And then she's got to walk 6 miles, and she walks at 3 miles per hour. So how long does it take her to walk? 2 more hours. And so that's going to be 4 hours total.
How long does it take her to get out the rope? How long does it take her to drag it to shore?
She's negligible time, we'll say. But in the real world, we might need to consider these things. So,
how strong is the current? Is there a cross current?
Yeah.
Pushing her away from the restaurant?
Yeah.
30 or 40 minutes.
Yeah.
She's running fast.
We'll say somebody's already considered all of those things in this problem. This is all the information we need to know.
The road speed straight down would be different than the road speed to the restaurant.
Yeah, what about the current?
It's today, and today only, in the history of all oceans, there is no
There's
difference.
She's right on the edge of a
Yeah.
current split, and
Yeah.
the current that way is the same speed as the current
Exactly.
that way.
Yeah. Today and today only in the.
Same friction.
Yeah. Okay. So, all right. So, it would be quicker for her to row straight to the restaurant. The question is there a middle ground
Walk on water.
where she rows to some point here and then walks the rest of the way that would actually be faster than either one of these options? Because her rowing is not as fast as her walking. You know, if she could walk the whole way, then, yeah, she could walk on water. She would be able to get there fastest. But that's not an option for mortals. So let's consider this situation here. So, I have picked an arbitrary point right here. I do not know where it is at. I'm going to have to name either this little piece right here, X, or this little piece right here, X. Let's go with this piece. I think it's going to be a little bit easier if we call this piece right here X. Okay, so if that piece is X, what is this piece? We don't want to introduce another variable. 6 minus X. So our equation for time, I'm just going to call this the middle ground scenario. So our total time our equation, I'm going to go ahead and do the walking part first. It's easiest, right? Walking, the distance that she's going to walk is going to be 6 minus X. And what would we have to do to get the time that would take? Divide it by 3 because that's how fast she walks. To get the other part, we need to know this distance here, which means we got to do Pythagorean theorem. So 4 squared plus x squared equals this distance squared. So we could just square root both sides. And so we got square root of 16 plus x squared is this distance right here. So this right here is the square root of 16 plus x squared. So we've got 16 plus x squared is our distance that she's going to row. What have I got to do to figure out how long it takes her to do that? Divide by that speed, so I'll divide that by 2. Now, we're going to do this calculator active. This can be done by hand, but it's just not worth our time to do that today. I don't think you'll get one quite that difficult that you'll be asked to do by hand. So let's grab our calculators. So I'm going to type in 6 minus x divided by 3 plus square root of 16 plus x squared divided by 2 I will admit it is possible to graph this, find a minimum point. But I'm letting you use your calculator on this to save us time.
Is she gonna have a calculator with her?
You're right. She would need to be doing this by hand.
She's got a boat calculator.
She's the kind of girl that rows out into the ocean in a rowboat
She's gotta keep a calculator.
alone 4 miles with no phone.
She needs a calculator.
She's crazy.
She needs a calculator so she can calculate fish.
She's crazy. And crazy people don't trust the government and don't have phones. So she does not have a phone. We, for our own benefit, are pretending that she has taken the derivative by hand. But we don't want to, so... Well, Connor, if you really want to take it by hand, we can, but...
Yeah, how does she calculate the miles out that she gets?
She got a rangefinder?
She does. She has that.
A rangefinder does yards.
She has one.
Maybe there's a buoy out there.
She knows where she's at. Trust me.
In the time of
I mean, this kind of person probably does, but
in the time of doing this, how far is
no
this,
phone,
how
but
far
a
has
weapon,
the current
probably.
drifted her away from 4 miles?
By the time she gets to the restaurant,
Just type Y and 1.
Yeah, by the time she gets to the restaurant, it's close.
All right, so if we take our derivative, all right, you can do Y1 parentheses X, closure parentheses. So you got to do Y1 of X. And then you got to do comma X. Derivative is F3. Do F3, I think it's the first one there. Okay, so here's our derivative that she took by hand because she does not have a calculator, but we're cheating because we're weak. She is not. I'm going to call this T prime. Yes. The derivative is going to tell us where this function is increasing and decreasing, which is going to tell us where maximum or minimum is at. And that'll tell us the point there. That'll tell us our value of x, so how far in here. So when we find the derivative, we want critical points. So we're going to set that equal to 0. I'm going back to no calculator because I'm...
Oh, it fell out into the ocean. Darn, you dropped it.
Square both sides. I might go back to finding the calculator here in a second now. Let's see how bad this gets. That's not too bad. It's pretty easy. And that it still works. She never had a calculator. I'm telling you, she's crazy.
My second rule.
Um,
The calculator in her brain comes and goes.
all right. The other day, as I was pondering teaching methods, I decided that what I needed to start doing in pre-cal is just giving them like a page of random equations, all different kinds of equations that they need to solve. Because the problem in pre-cal is I give them equations, and all the equations are the same. And we learn how to do those, and then we go to something else, and then we do all these. But they never see them like all mixed together very much. Trig identities you kind of do, but that's why they're so hard. You need to start doing that. Mm-hmm. I'm squaring both sides to get rid of the square root over here on the right-hand side. Yeah. Yeah. And so we will square root both sides. The negative is not going to be a good answer, so we're getting square root of 64 over 5, which because she is a mathematical genius, she knows that the square root of 64 divided by 5 is 3.577. Now, more than likely, that is going to be our minimum point. But you can plug a number back into the derivative to see that for sure. So if we plugged in like a 1, actually 1's not great. 3.57771. Actually. Alright, so if I plug in I guess I can plug in 0 to that. If I plug in 0 over 2 square root of 0 squared plus 16 minus 1/3. That is 0 minus 1/3, which is negative. If I plug a number bigger in, like 5 over 2 square root of 5 squared plus 16 minus 1/3. I got 5 over... Is that going to give me a positive number? 25.
Do like a really big number, like 100.
I don't know if that's going to be even helpful. She is a genius and can do this in her head.
Her brain calculator came back.
Yeah, 2 square root of 5 squared plus 16. Yep, it is positive. I figured it would be positive just because I knew that needed to be our minimum point, but I was hoping I could determine that from my own ability, but I could not. All right, so since we go from negative to positive, this is a minimum point. Since that is a minimum there, then she should row to this point that is 3.57771 miles away from shore, or away, I don't even know how to explain that, away from the point perpendicular to the shore. So she should take this path and then go across here. If you want to see how much time it would take, since we've already got this plugged in, if you do y1 of 3.57771, because our equation that we typed into y equals was our time equation, then you will see that it takes 3.491 hours. So she saves herself about 0.11 of an hour which
Totally worth it.
is, oh wait,
How long would that have taken her to solve? She would have saved herself that much time.
yeah. So take a little over 6 minutes off of her trip, which we can say if she was sitting out here figuring this out would have just wasted her time, right? Because it's taken us like 15, 20 minutes to do this problem. So I realize that I'm not making this look very useful by giving you this problem, but we will do another one tomorrow where you hopefully will see
It was fun.
the usefulness. But it was fun. She should row to a point that is 3.7771 miles upshore from that closest point. So this right here is the closest point. So she should row 3.57771 miles towards the restaurant from that point. Yes. X is what would give us minimum time. So, like when we wrote this equation right here, our time equation, that is what we're trying to find the minimum of. So we're not like making X a minimum distance, we're finding the X value that would give us minimum time. So, to see if it is a minimum. And most of the time, especially when you only get one answer, it is the minimum. You know, if you didn't check, you'd probably be okay most of the time. But it is going to be a minimum. So, now, in a world where she does not have a calculator, and she is having to, so like she cannot graph this and find the minimum point. So if she cannot graph this and find the minimum point, the way to find the minimum is to take the derivative. We want to know, she wants to minimize her travel time. She wants to know what would be the quickest. So it'll be the quickest route. Yeah. Yeah. So, like, you know, we talked about the option of just going straight there, which was 3.6 hours. We talked about the option of going straight to shore and then walking. That was longer, right? So what we were trying to figure out, was there a point somewhere in between here that would actually be faster than either one of those options? And there is. Because this equation right here that we set up gives us the amount of time that it takes her to walk or row/walk that distance, right? So this part of the equation is her walking section, and then this part of the equation is her rowing section. So together that tells you the time. So like that's what I have in Y1. Like if I plug in Y1, all right, quiet please. If I plug in Y1 of 0, it gives me 4 hours, which is what I got here. So if like she goes straight here, if X is 0, she goes straight here. If I do Y1 of 6, it gives us, well, green button. It gives us that number we got over here, right? And so X is the distance from this point to wherever she's rowing to. So 0 would mean X is 0. So that would mean that she goes to this point. So that distance from the point is 0. If X is 6, that means she doesn't. The X is all the way over here at the restaurant. So she would go straight to the restaurant. But the quickest way for her to get there, because she can walk faster than she can row, is to go sort of like a middle ground spot here where she rows sort of diagonally but not all the way to the restaurant and then walks part of the way. Okay, questions? All right, those are some of my favorite problems. All right, let's look at example 4. All right. Okay, let's see if he's right. Oh, you worked the last one here. Okay. 2 posts, one 12 feet high, the other 28 feet high, stand 30 feet apart. So let's draw this. We've got a 12 feet high post and a 28 feet, 12 feet. They are 30 feet apart. They are to be stayed by 2 wires attached to a single stake running from the ground level to the top of each post. Where should the stake be placed to use the least wire? So let's imagine that our stake is right here, and we're going to put a wire here and a second wire here. And so we need to use the least wire, so that what we're minimizing is our amount of wire that we're using. So we need an equation that gives us the amount of wire. And we would prefer for that equation to be just one variable, not 2. Right? So, what do you think? Okay, so we can do sort of the same thing we did on the last problem. I'm going to let this right here be x, and this part right here be 30 minus x. So if I want to find the length of my blue wire here, blue wire would be 12 squared plus x squared equals, I'm going to make this a b. B squared for blue wire. So I'll just square root both sides. So B is going to equal the square root of 144 plus x squared. For my red wire, I'm going to call it R for right now, we would do 28 squared plus, right here I got to do 30 minus x squared, would equal the red wire squared. So 28 squared is going to be 784. Plus, we're going to square double square here, so we'll get 900. Right? There's 9,000. Where's my brain not working? 900. Minus 60x plus x squared equals r squared. So we'll put these two together. We'd get 1684 minus 60x plus x squared would equal r squared, and we could square root both sides there. So r is square root of 1684 minus 60x plus x squared. So that would be the length of our red wire. And so what we want to write is an equation for the amount of wire. So I'm going to call this W for our amount of wire. It would be B, which is square root of 144 plus x squared, plus R, square root of 1684 minus 60x plus x squared. Now, again, I'm kind of putting like imaginary calculator restraints on you here. You could graph that and find a minimum point using Desmos. That would work, but because I want you to like understand the calculus reasoning behind it, I'm putting imaginary calculator restraints upon you here, and I want you to do this the calculus way by looking at the derivative. However, I just don't want, you can take the derivative of this by hand. It can be done. You can set it equal to 0. You can solve. You can do all that by hand. I just don't want to make you because it gets extensive. So if we look at this, if we type this into our y equals if we go to our, so I put that into y1. To take my derivative, I can tell it derivative y1 of x, comma x. And so I get all of this. So w prime is x minus 30 over the square root of x squared minus 60x plus 1684 plus x over square root of x squared plus 144. So again, we could do it by hand, but we don't want to. What would we do once we find the derivative? Set it equal to 0 to find your critical points. You can copy this. So if you do, if you go up to that line, if you do, where is it? Green button, and then that up arrow, it copies that. So you can either just use the copy paste feature like you normally would, or you could go to y equals and put that in y2. And you can look at the graph, or you could use the solve feature. Solve feature should work fine for this because it's not trig, hopefully. If it doesn't break it, sometimes it breaks it. So if I do y2 of x equals 0, comma x. Oh, I didn't hit the green button before I hit enter either. Oh, it just gives you 9. So we get x equals 9 as our critical point. So w prime, we'll put our 9 right here. And I'm just going to look at the graph, although my window's bad. Oh gosh, what have I done? I could have plugged the number in quicker than this. Alright, window. Let's see. I'm just going to, I just need to see. I'm going to go back here to y equals. I'm going to take out y1 now. I don't need it. Do I? No. And I'm going to just do zoom 6. Because I just need to see what happens at 9.
Stops.
I'm pretty sure it doesn't stop. I'm pretty sure it crosses at 9. Alright, let's do zoom fit. Let's see if it'll If you do F2, it's the last one, I think, on my list.
Signature.
It doesn't even want to do that. I'm pretty sure this is going to go negative positive. I feel pretty sure about it. Which is what we need because we want this to be a minimum, right? I'm spending probably more time than I should on that. If you make the assumption it's the minimum, you'll probably be safe most of the time. So the stake should be placed 9 feet from the bottom of the short post. And that would use your least wire.
What if you just said 90 feet from the short post?
Yeah, I think that'd be okay. In general, the directions on the AP exam tell you to write in complete sentences, but they don't take off if you don't, as long as your idea is conveyed completely. All right. I got one more I want us to look at. All right. 4 feet of wire is to be used to form a square and a circle. How much of the wire should be used for the square and how much should be used for the circle to enclose the maximum total area?
2 and 2.
Okay? So, we got a square. We got a circle. And with the square, I want to know one side of the square, right? And then with the circle, I'm going to call that the radius. So, what is our formula that we are maximizing? Area. So, area of these two figures, the area of the square would be x squared. The area of the circle would be pi r squared. Right? So, and this is like an example of one that you might be given, and they're not going to give you those formulas. Those are ones that they would expect you to know. But we need, that has an X and R, so we need something we can plug into that. They do tell us we have 4 feet of wire. So that is the wire is the perimeter of each figure, right? Because that's what's used to make these. So for the square, it'd be x plus x plus x plus x, which would give you 4x. What is the perimeter of a circle called? Circumference. And what is your circumference formula? Nope. Almost. Just 2 pi r. It is also pi times diameter, but you have to use the same. You have to use the same variables for this. So we need to solve this either for x or r, and then plug that into this equation. It really doesn't matter which one you solve for here, because neither one of them are squared. You can solve for either one fairly easily. Which one do you guys want to solve for? R. Okay, so if we solve for R, then we are subtracting that 4x. So we got 4 minus 4x equals 2 pi r. And then we divide by 2 pi on both sides. So R, yeah, let's factor out a 2 out of that top. So we got 2 minus 2x and the 2 pi. And those 2's will cancel. So we got 2 minus 2x.